So this is a Leetcode for one question, which is an easy one. Here we are given numbers of non-repeating order, and what we have to do is we'll be given a target of 9 in this case, and we have to find the two numbers whose sum will be equal to 9, in which case 7 plus 2 is 9. So in this one we shouldn't return the numbers. Instead we have to return the indices of the numbers. In this case it's 0, 1, 2, 3. So we have to return an array like this. So this is a question. It's pretty simple. It has a little trick in it, but once you get that thing, it's easy. Before I jump into the explanation, 2 points. The same number can be considered again, which means that you can't consider a particular value if you have t is equals to 4. You can't consider 2 times, which means you can't return 0, 0 again. It's invalid. It's wrong. The second point is has exactly one solution, which means this question will have, for a particular target test case, we'll only have one solution. So if you have another solution such as if you have t is equals to 9 and you have another one which is 8, 1, you don't have to return 4, 5 again. You don't have to return this. You have to return the first two elements whose sum will be 0, and it won't even happen in this case because Leetcode already provided us with the information that this has exactly one solution. So there is no worrying about edge cases such as having no solution for that array. It will happen. So let's get to the problem statement. So here let's get to the problem statement discussion. We are given an array like this. We will be given a target value, and our job is to find the indices of two numbers whose sum will be 9. So how do we approach this solution? First is obviously we iterate through each and every solution of this array, which means you can go through and start with 2, and you can see the sum of 2 plus 11 is equals to, you can see that 2 plus 11 is equals to 13. Now you can go to the next one. 2 plus 7 is equals to 9. Go to the next one. 2 plus 15. Oh, you already had 9. So now you see that 2 plus 7 is 9. We got the answer. But in this case, what if the 2 was not here and instead was here? That's problematic because now you have to iterate to each and every solution. 15 plus 11, 15 plus 7, 15 plus 2, 11 plus 7, 11 plus 2, 7 plus 2, and then you'll get the answer. And as the length of the array is greater than 1000 or some other value, and it's greater than 100, it's going to be problematic to solve this thing. So O of n square is this one, which is not optimal. We can use another one which is O of n. Now in order to solve O of n, we need to think of a logic. What is it that we are repeating that we can save? What is the repeating work that we can save in this case? So now let's get into the O of n problem. We know that we have to find two numbers for the target value, which is like in this case, and we know we have to iterate it only once. So we have to iterate through the array only one time. So how are we going to do it? So we can't iterate through the second time because TwoSum means we have to go through two numbers. So let's take this thing. Since we can iterate once, let's take this value as array of I. So for each and every value of I, we'll iterate this thing here. So this is the only thing left here. This is the reason why we're getting n square, and this is what you have to resolve in this case. So how do we do this? How do we know whether this value exists for 9 or not? So let's do one thing. Let's take a bag in which we can store values as we go. Now since we're iterating once and constant time takes for storing one particular value, so what we'll do is as we go through each and every iteration of the array, we'll be storing those values as we go. So when 5 is over, we'll store 5, 1 is over, we'll store 1, and 7 and so on. As every number iteration happens, We'll store the previous iterations value in this bag. Why are we doing this thing? If you understand this thing, just take this as x. Take this as x. X is the value here. So for the array of I, you need an x such that the value will be 9. So here I have taken 15 instead of 15 and 11. We have taken 5 and 1s just for simple explanation. So let's look at this one. For example, if we have array of 5, we first write 5 and then x is equals to 9. So for what value of x will the answer be 9? It's 4, right? For x of 4, the answer will be 9. What we're going to do here from now on is, for each and every iteration, as we go, we'll check in this bag, is 4 there? It's not there. The bag is empty because we only started this thing right now. So, since 4 is not there, we'll move on to the next iteration. But before we move on, just add 5. Just add 5 here. So now we add 5 in this bag. So, in case if there was another iteration where 4 was there, what happens here is, when you go to the next one, yeah, we go 1. So what happens here is 1. So 1 plus x for 8 will be 4. 8 is not there. So we'll add this thing 1 and we'll go to 4. Now this value is 4. X value of 5 will be 9. So 5 is in the bag. Here you can see that we don't have to iterate this thing again. We can just check in this bag whether the value is there or not. So now we found the value, 5 is there. What we can do is we can simply return this index. So we finally found 5 and 4 as a potential match for this thing. If 5 wasn't there, if 4 wasn't there in this case, so it was 7, then what happens is 7 of 2. 2 is not in the bag. Now we haven't reached this 2, so don't worry. 2 is not in the bag. That's all we should think about. 2 is not in the bag, so what we'll do is we'll add 7. That's it. It's okay, it's here, but don't worry. 2 is not in this bag, so we'll add 7 and we'll move on. The next one. So now it's 2. Now x is 7. 7 is in the bag. Yeah, I know 2 is not in the bag, but 7 is when we iterate this thing. So no matter which way you iterate, whether this be the first one, this be the first one, the alternate, this number will be added in this bag. So we'll again get the value of 9. So there are two things here. The two things you should be doing here is, first one adding in the bag, and the second one checking whether it's in the bag. So for the adding in the bag, we'll use hash maps, which so from the 2, the first one you should add it. So for adding, we'll use hash maps. So hash map basically stores a value based on its key value, key pair. So for 5, what we can do is we can store 5 and 1 and 7. So like that. Yes, for the particular key value, we'll also have a number associated with it. We have two approaches to solve this thing in the hash map too. One is a naive approach, and the other one is much more optimal. So we'll look at both of them. But in order to add this thing, we need a hash map. So for checking, we need to look at the function. So how are we getting the value of x? Already know that 7 will be 2. When we get the array of 5, look at this thing. If we just remove this, it's 9, right? Array of I plus x is 9. So how do you know the value of x from this thing? We know this and this. So what we can simply do is, x is equals to 9 minus array of I. That's it. So simple thing is, we can just subtract this number from our array of I value to get x. So this is just checking function. That's it. You just check whether the value is there in the hash map or not. This is the first part and this is the second part. The first part only adds the values as we go to the iteration, and the second part only checks whether this value was there to satisfy our condition of target. In this case, x is equals to target minus array of array. These are the two things we will use to convert it into OFN. So let's look at the two solutions for this one. Okay, so now let's look at this code. We'll go line by line using this example. This is the array we are given, and the target, of course, we know is 9 at this point. So we'll take a hash map. So in this case, for this map, what we'll be doing is we'll go through the count of each and every value in this array for storing the key value pairs of the map. So now, next we look at length. Obviously, length is equals to len of nums. I told you right in the previous video, you shouldn't use the function here. Rather, create a variable and use a function here. Use the variable here. So now we'll be iterating to this array, right? So in this array, the array, by the way, the name is nums. This is target. So in this case, we'll iterate through each and every value, which is our what did I say is equals to t, right? So this is that iteration for n. This is the n time complexity that we need. In this case, for simplicity's sake, what I did was I took two numbers, two variables a and b. So a is equals to nums of I. Obviously here basically this is a nums of I, and b is equals to t minus a. This is b. Obviously we had discussed in the previous one, for the finding out of b we need this equation b is equals to t minus a, and for finding out of a we just added thing. We go through each and every iteration and we get find value of a. So now to find b now, whether the b is in the hash map or not, in the bag or not, what we have to do is check if map of b is not equal to 0, which means in this case, what is the answer for the first iteration? We'll get the target is 9, I is 2, so it's 7, right? B. So for this map, let's draw the map here. Seven in this map. Currently the map is empty, so 7 is not in the map, right? So what we do is we'll just go to this other line, which is map of a plus equals to 1. Now we checked whether 7 is in this or not. It's not. So for adding, what did I say? We have to just add the value that we iterated through once. So 2 will be 1. We checked it and now we're adding it. So we'll go to the next iteration, which is 15. So now 15, we'll get the answer is minus 6. Right? Yeah, it's minus 6. So is minus 6 in this hash map? No. The only thing in the hash map is 2, which has iterated once. So we check the value again. So this is not there. So what happens is this condition does not satisfy. So we'll go to the next line, which is we'll add this 15 again in this map. So we checked again and we're adding the value again. So 15. Next go to 11. Same thing. 11 is 2. So minus 2 is the answer. Minus 2 is not in the hash map. 2 is, but minus 2 is not in the hash map. So we'll again consider it as adding it by 11. 1. Same thing. We checked it, we're adding it. Again, we'll check again. 7. 7. So for this one, the value is 2. Let's see, look at this one. 2 is in the hash map. The map of B, which is map of 2, is not equal to 0. Yes, correct. Because the map of 2 is equals to 1. See what happened now? This condition is satisfied now. For that, what we do is, once this condition is satisfied, since they said that there will be exactly one solution, so of course we don't need any return statements here. The only thing we'll get is return I comma num dot index of b. So since we shouldn't return the values themselves, we should return the indices 1, 2, 3. So we have to return 0, 3 here. This should be the answer. in array form. So I we already know, we already at third one. So we'll get, in this case, not 0 comma 0, we'll get 3 comma 0. It's okay. Leetcode said we can return it in any value, any method we want. So first we'll get 3 for I. Next, for num.index, what we're doing is we're finding the first occurrence of the index of the first occurrence of b. In this case, b is 2. So it will go through this and it will say it's 0. So we'll get 0. This is good. This is good. What we're doing is we're basically using the hash map by finding the frequency of an element. That's the basic point here. The hash map is used for finding the frequency. If 2 was occurred another time, then it would be 2. So we don't need that, but that's what we're doing it. We're checking whether it is there in the bag or not. It's optimal. It's sure. If you've done this thing, if you've got through this thing, much more easier to come get the idea of, but it's optimal. But the problem is this function here. This thing is O of n. So what you'll basically get is O of n for this first one iteration. First array of I will get O of n plus, worst case scenario, it could be somewhere in the behind. So you'll get O of n again if you have to check it, because to check that value, whether it's there, where it is, and what is the index. That's the function of method. So we'll get O of 2 times of n. This is what you'll get. Good, but we can make it better. We can just make it O of n. It's a little tricky, but you'll get that thing if you think about it a little. Why are we using a hash map for storing the frequency of value when we can directly store the index of the value? See, now when this happens, you don't need num.index. You already know the index. The existence of this 2 itself shows the fact that 2 exists in this map, which means 2 exists in this array. We don't have to use a counter. We don't have to put 1 or 2. The fact that a number is in this, a key value is in this hash map, shows the fact that the number is in the nums array. So you don't even have to go further. We don't need to find how many 2's are there. We just need to know 2 is in the hash map. 2 is in it. So once that is done, so we can basically use this key value storing to store the index of the 2. So for each and every iteration, not only will be storing 2, but it will store the index of 2. And this is where this part will get eliminated. That's the basic concept of this thing. So basically what we're doing is, instead of storing the frequency of an element, we're storing the index of an element, so that we don't have to use this thing and we'll get an O of n, the true O of n solution that we're looking for. And in order to store this thing, all we have to do is, instead of adding map of a plus is equals to 1, we just add a map of a is equals to, what is it? Map of a is equals to nums of I, then nums of a. Map of a is I. Took me a while to realize it. But so what happens is, map of a is equals to I. We can just store map of a is equals to I. So not a lot changed, but I'll rub this thing out and I'll explain this thing again. Let's start. Map of with the code is basically the same here, except for this one part. Actually, I don't know why I erased it. I could have just written this thing. Okay, so let's start. The only thing that changed here is this part, this one map of a. I don't know why I erased it and wrote it again, but it's okay. Map of b and map of a of I. These are the only two things that we changed here. So let's get into it. This is the same thing for I. We use a length for len of nums for I in range of length. Yeah, it's over. A of nums of I. I'll get into these two comments here later. And next we have b is equals to t minus a if map of b. Here's where the thing comes. So as I said before, in this case when I'm storing this thing, do not actually check whether the value of 2 is greater than 1 or 0. If the value of 2 is 0, it'll just stay 0. It won't even be in there. The value won't even be in this case. If the value of 2 was 0, 2 wouldn't even be in here. In order for 2 into even be there, should have a value. So why not, instead of storing the value of 2 as 1, why not just store the value of index in this case, so that we don't have to again look at the index when we need to return this thing. That's why not writing if map of b is not equal to 0 or greater than 0. We're just writing if map of b is there. Does it even exist? That's all we're concerned about. If map of b exists, don't even need to look at anything else. Whether it's greater than 0, whether it's 3, whether it's 10, we don't need that, because if it's there, we can add that thing. That's it. Simple. Map of b, then return map of b comma I. Basically what we're doing is, if we look here, this is the thing, map of a is I. We're storing the indices of each and every value. 15 1, 11 2, 7 is 3, but we don't need to go through 7. What will happen is, so when we go to map of b is, we get here 2. For if we look at 7 again, we don't have to go through everything again. We can just go here and look at for I. 7 2 is the map. So map of 2 is 0. So 0 comma I is 3. 0 comma 3. We got the thing. We don't have to use the function again. It will be truly O of n. So before we go to the code, let's look at these two comments, which is actually for the code, but I'll just explain it here. Yeah, so first we can use enumerate. Instead of writing this thing for I in range of length, we can just use I comma n, and there's a function called enumerate in Python. It's applicable, yeah, it works. It's up to you whether you want to use it or not. It just makes the code much more smooth and simple. And the second thing is, we don't need these two variables. Now, a and b are required, but the variable a and b is not required here, because what happens is, if map of we can just write b instead of b here. Instead of not writing this thing, we can just directly write map of t minus nums of I. Yep. Map of nums of I. Here we can write, instead of a, map of nums of I. If you understood what I said. So don't need these variables. The code is just this much. This is the code for this thing. So we'll get into it in the code explanation video part, but I just explained this thing. We don't need to use variables all the time. Sometimes when you're writing the code, you have to make it much more efficient. So in this one we are using the index of a value to stored in the hash map. In the previous one you're using the frequency of a value. In this one you're using the index of a value. So this is truly O of n. Just iterate to it once. You already store the index and you also store the value. So when you go to another one, when you find this function, when the checking, you can add and you can check, and when you check, if you get the value, you return the value. That's it. So we'll get into the code. We won't waste any more time. We'll just jump into the code now. Okay, so this is the final code here, and okay, if you look at it, we use default dict here, default dict of int for creating the map. For length, we still use the same thing, length for I of len, and all this thing is the same thing. Okay, the previous section I told you we don't need a and b. The thing is, we actually do need those two variables here. I wasn't thinking straight in that case. Let me tell you the reason why. I told you we don't need a and b because it's simple. It's much more primitive way of writing it. We need to actually write directly nums of target minus nums of I, and we can again write target nums of I here. I basically told you the same thing before, that we shouldn't actually be doing that because it increases the number of functions we have to perform, and I myself told you that we should be doing that, so I'm sorry for that. I'll tell you why. Okay, this is an opportunity to grow. Let me tell you why we shouldn't do what I just told you to do. If you look at this thing, map of I, let's look at the asymptomatic notation of time complexity for this is O of n. We all know that. Let's not talk about it. We'll check at the actual time complexity, the actual time it takes to write this function down. This we won't even consider it bits declaration. We don't need to. We'll look at this length. Here we are saving it. Length of nums. We're doing it once. Variables don't take time. So that's it. We'll use this as a function. This is a function. So we'll take one time for that. For now we'll jump into this. So for loop takes n time. But in for loop we'll look at each and every iteration. A is equals to nums of I. To find nums of I, it's O of 1, but still it takes time. So O of 1. It takes time to find the number from the array. If you have an array, you have to go to the index and you have to find it. So it takes time. B is equals to target minus A. It's an operation. It takes one time. Map of B checking takes one time. Map of A of I, we are adding. To add it, it takes one time. So for checking and adding itself, it takes two units of time. So the final time will be 1 plus 4n. This is the time you'll actually take. Don't worry about O of n. Yeah, O of n obviously it's there. Our job isn't to just asymptomatically check whether it's O of n or not. Our job is to actually create an efficient code which is optimal down to its core, not just this stupid O of n. Yeah, it's O of n, so we don't need to worry about it and everything. This is what you should actually be looking at sometimes, because in competitive programming they won't ask O of n. When they're feeding it to the computer, they'll have a particular time like 0.45 milliseconds or some time like that. This time doesn't know O of n. It won't say, oh, it's 0.44 milliseconds, which is approximately equal, so we'll let it. No. The code should be less than or equal to this. If it is 0.46, it's greater, so it won't work. That's it. Sometimes it's those small little differences like these ones, 1 plus 4, and if you had added that thing, we would have added more ones. Few more ones would have been added, which would be 6. This is not a lot, but this is a difference that you may lose in a particular in any code that you are writing. You should be careful of that. Yeah, I know I was the one who told you that. I'm sorry. This is how you actually do it. Use as many variables as possible. Use as many variables as possible, because variable stores time. Variable stores space. Space can be stored. Yeah, it can. You can use how much ever space you want. Time is the important case here. Sometimes we need both space and time to be optimal, but in most cases, time is the one which is more important in this case. Time is what we should be looking at. Space you can use as many as you want. Length is an array. B is one. Length is a value. B is a value. A is a value. These all are variables. By using these variables, you decrease the number of times you have to repeat another function. This length, if you wrote length or len of nums here instead of length, what happens is for each and every iteration, this length will also be added. In which case, another one will be added. So if you don't write nums of I, for each and every time you'll also calculate nums of I here, and for nums of I here, B for that value also. So you'll be adding another 1, 1, and 1. How much is it? 1, 4, 5. 5. 1, 2, 3, 4, 5. These are the number of ones you should be adding if you do that thing. So round out to 1, 9. We just went from 4 of n to 9 of n. Just decreased it to 4 of n. You removed all these other functions that you have to do again and again. Remove this one too. Just decreased it to 4. So the bare minimum will always be there. These two, the checking and adding, which I told you, this will always be there. This checking and adding. But for these and this one here and all, you see the time there. And for this one too, by adding this variable. So that's why never ever try to simplify a code by writing it here. The lines will be less. No. If the lines are more, it's okay. Just write those variables. The functions and the computation of the time it takes for the function will be reduced. So remember, keep that in mind. So that's it for this code. So yeah, this is the final algorithm for TwoSum. You can write it down. Maybe I should just upload a GitHub. So this is the final code. You can write it down. Okay, this is the final algorithm for TwoSum. You can write it down. From the next video onwards, I will upload all this code on GitHub, so that you don't have to write it down again and again. I know the first and second one you had to do it, so I'm sorry. Thank you.